try again. Okay, hi. All right, so 10.5 is all about dividing these fractions that have radicals in them. And they really want you to get rid of the radical symbol. They want you to, when you get rid of it and it just is part of a fraction, that's called a rational, not a radical. So when they say rationalize, see the base word rational in there? They want you to get rid of the radical. That's what they mean. So, and in this case, most of the time they're going to tell you to get rid of it in the denominator. But they could tell you to get rid of it in the numerator, and it's done the same way, you know, either one, so that's not such a big deal, but pay attention to those directions. And how we're going to get rid of the radical symbol in the denominator is we're going to multiply by something that makes it solvable. And when we multiply, we're going to make sure we're multiplying both the top and the bottom of the fraction. Even though it's just the bottom, we want to get rid of the radical on. So let's come over here to the radical, the square root of 5 over 3. We're going to rewrite it as the square root of 5 over the square root of 3. And since they want us to rationalize it in the denominator, that means they want us to get rid of the radical symbol in the denominator. So we can't solve this. I don't know the square root of 3. But if I multiply it by something, I do know the square root of 9. So if I multiply here by the square root of 3, it gives me square root of 9. And since I did that on the bottom, I'll also do that on the top. And so the top becomes square root of 15. All right. So now that we've done that, we can solve the bottom. Square root of 9 is 3. And on the top, I can't do anything about that. It's just still square root of 15. And this is what we would say, so a division problem that has been rationalized because it has a rational number on the bottom. It does not have a radical number on the bottom. So you're multiplying by something that makes it solvable. And it could be a variety of things. For example, here. If you have the square root of 1 over the square root of 2, now I don't know the square root of 2, but if I multiply by the same thing on both the top and the bottom, then what I come up with is the square root, sorry, not drawing that very well, square root of 4, and we have square root of 2 here. Now, this part's solvable. So our final answer is square root of 2 over 2. Not too bad so far. Okay, so down here, this gets a little bit different because it's not square roots, it's cube roots. But we're going to set it up like we did with the others, kind of rewrite them, top and bottom separate from one another. Okay. Now, I don't know the cube root of 25, and I don't know the cube root of 3, but that really doesn't matter. Sorry, I got ahead of myself. I need to rationalize the denominator. And if you go back to that list of cubes that we made earlier, so here's my cubes. And I'm looking for ones that I can use that involve 25. And notice right here is one. So we know that 5 cubed makes 125. So if I take, where'd I go here? There we go. So if I want this to be 125, I'm going to multiply by the cube root of 5 on both levels, so that this bottom part becomes cube root of 125, and then it becomes solvable. And then the top part would be cube root of 15. All right, so, oops, sorry, I'm running into my next problem over there. So down here, we're going to keep the top part the same, cube root of 15 over the cube root of 125 is 5. 5 cubed is 125. And that is a fraction that has been rationalized in the denominator.